Hi everyone. Today I'd like to talk about the topic detection. So, as an introduction, I'd like to talk about what it is and why it is important. So, topic detection is actually to detect a topic or topics of the words in a bunch of documents called corpus, which is a collection of documents. And why it is important is that so, for example, if I want to search for a keyword kidney, then I don't know which words are actually related to kidney, the keyword kidney. But then, so the only way would be to Google in a dictionary. But then, with these topic detection algorithms, we can actually automatically detect those related words based on the occurrences in from the previous data set or from the given data set. So we actually applied our algorithms to the data set called PubMed, which is uh, which is the data set from life science journals and online books called Medline. And so for this topic detection, we actually tested three algorithms, which are called LDA, NHDP, and HLTA. So LDA is the short term for latent Dirichlet allocation model. So LDA assumes that a word or words are generated from some latent variables, some topic variables. So the process is like this. So first we have to select the topic distribution for each document, and for example 0.3% 0.3 proportion of topic A and 0.7 of topic B. And after we have this topic distribution for a particular document, then each topic is selected. So topic A with probability is 30% and topic B with 70%. And after this topic is selected, each topic, so for example, topic A or topic B has its own distribution for a dictionary or for a collection of words. So topic A might say that word alpha will occur with a probability of zero point 0.5 and topic B with maybe probability of 0.3. So each word in a document in corpus is generated as follows. It is called latent Dirichlet allocation because all the distribution has the prior for with the Dirichlet processes with some prior hyperparameters. The next algorithm we tested is called NHDP, a short term for nested hierarchical Dirichlet processes. It is basically like LDA, but then it is nested and hierarchical. And the third one is called HLTA, which is the short term for hierarchical latent tree analysis. So the HLTA is basically latent tree models in hierarchical manner, but then what it tried to overcome is the difficulty that latent class models had before. So the latent class model assumes that each word has only one domain of latent variable, but then HLTL assumes that there are multiple domains for each word. So this is the difference. And the experimental setup is as follows. So we chose the dataset called PMC005, one of the dataset from the PubMed. And this dataset is chosen because of resource scarcity. And the dataset is the smallest out of all in the PubMed. So for the pre-processing of the dataset, we first converted, of course, all the words to lowercase, and all the stop words and non-alphabetic characters were removed, like semicolon or some numbers, which are not words. And also, there are some English words that look similar but then have the same semantic meanings. For example, the word go and goes should be the same, should be of the same meanings, which is called lemmatization. And the words shorter than 3 characters were removed, so which would include the word like articles or the or how. And after this basic pre-processing of the data set for the words, an algorithm called TF-IDF is introduced. Uh, is adopted, introduced by someone else. And TF-IDF is a short term for term frequency and inverse document frequency. So what TF-IDF tries to do is to penalize those words that occur too many times, but then still meaningless. So for example, the word like what is not really meaningful for topic detection because what cannot be, not cannot be, but is usually not a topic. So the term frequency term in TF-IDF tries to reward those words that occur a lot in a document. However, if the term like what may occur a lot in a document, but then TF-IDF also penalizes those words that occurred in every document or in most of the documents. So for example, the word what not only appears in document A, but it should also appear in document B. So this frequency called inverse document frequency is penalized, and this term frequency and inverse document frequency terms are combined by the product and summed up for each word in the 2000 words selected. So yeah, again in details, in other words, based on the TF-IDF scores for each word, 2000 words with the high score have been selected. Next, we're going to talk about the bag of words and binary representations for each document. So basically, bag of words representation for a document expresses the document with the frequencies of each word. So for example, if a word dog appears 4 times, then the document should have number 4 for the dog, for the corresponding index of the word dog. However, with the binary representation of a document, even though the dog appears 4 times, then the document representation vector should only have the boolean 1 for the dog, for the word dog. And for LDA and NHDP, we can use both bag of words and binary representations for the documents. However, for the HLTA, we can only use the binary representation, which is also one of the limitations of the model HLTA.